In this lesson, we're going to talk about some properties of exponents, specifically multiplication properties. Let's just look here. If we have 8 to the second power times 8 to the third power, what that means is we take a times a, that's this a to the second right here, and we multiply it by a to the third, which is, well, 3a's. So we have a to the second times a to the third. Well, if you count these, that's going to be in simplest form a to the fifth. A to the second times a to the third ultimately will equal a to the fifth. This kind of lends itself to one property, which we'll talk about in a second. Now, if you look at this next one here, we have a to the second, then raised to the third power. What that means is I have 3 of these a to the seconds. 1, 2, and 3. So I have 3 a to the seconds. Well, a to the second means a times a times, again, a to the second means a times a, and a to the second means a times a. So we end up with 1, 2, 3, 4, 5, 6. In this case, a to the second raised to the third ends up being a to the sixth. So if we look at this first property right here, that lends us to this one right here, product of powers property. And I don't expect that you know the names of the property. I expect that you know how to use them. What the product of powers property states is if you have two numbers with the same base, meaning they're both a's, or in this example they're both 3's, whatever their exponents are being multiplied, product means multiply, you add their exponents. Isn't that what happened here? This is like saying a to the second times a to the third, or a to the 2 plus 3. And that's how we get a to the fifth. So this property here, the product of powers property, says that if you have a multiplication problem, same base, you add their exponents. So for this example here, 3 to the second times 3 to the seventh, since they're both 3's, we're going to add 2 plus 7. If you look at the next example, this lends itself to the power of a power property. Again, I don't expect you to memorize the title of the property, but you need to know how to use it. What the power of a power property says is that if you have a power and you raise it to another power, you multiply the exponents. Like right here, a to the second to the third is like saying a to the 2 times 3, which will give us a to the sixth. So for example, if you had 5 to the second raised to the fourth, you can just go 2 times 4 and get 5 to the eighth. The last property in here, which we didn't really have an example of, is the power of a product property. It says to find a power of a product, find the power of each factor and multiply. So if we have the product a to the a times b raised to the m, that's like saying a to the m times b to the n. Remember, this is power of a product property. This is not the same thing as saying a plus b raised to the m. That's different. We're multiplying here. So if you have in parentheses 2 numbers or variables being multiplied, then being raised to a power, you can take each individual part raised to the power. For example, 2 times 3 raised to the 6. That's the same thing as saying 2 to the 6 times 3 to the 6. Okay. The power of these properties is they make simplifying problems with exponents a lot easier, so you don't have to write everything out every time. Let's look at some examples. The first example we have is 4 to the fifth times 4 to the third. Now, they're same base being multiplied, so what we can do is just add their exponents. That's like saying 4 to the eighth. Again, if you had 5 fours and you had 3 fours, that's a total of 8 fours. Okay, same base being multiplied, add their exponents. If you look at this next example here, notice again we have the same base. They're all y's. They're being multiplied. So even when you have three terms, you can just add their exponents. If I have 3y plus 4y plus 5y, 3 plus 4 plus 5 is 12. So this simplifies to y to the 12th. And if you were to write that out, 3y, 4y, and 5y, you would have 12y. This next one tends to confuse people. Again, same base being multiplied, so people have a tendency to write 2 to the 6th because nothing's here. Remember though, how many 2's are actually here? What exponent can I fill in here? Not a 0, but a 1. So this isn't 2 to the 6th power, this actually is 2 to the 7th. Be very careful about that because that a lot of times is where the mistake is made. Anytime you have a single number or variable, it's raised to the first power. We look at one more example like that. We have -5 times -5 to the 3rd. Same base being multiplied, even though we're writing our multiplication with parentheses this time. Remember though, there is still -5 to the 1st right here. So this is like saying -5 to the 4th power. Now if you'll notice with all of these, I left them in exponential form. Your directions in your homework will say, write your answers as a power, or write them as a product of powers. Or if it says evaluate, that means they actually want you to fill it out and get a number answer. Okay. A few more examples. This is a power to another power. And remember, our power of a power property down here says that if you have a power and raise it to another power, you multiply their exponents. So 5 squared to the 3rd power is the same thing as saying 5 to the 2 times 3, which is going to be 5 to the 6th. Again, you can just leave it as 5 to the 6th. In this case, your direction probably would say write it as a power. Looking at the next example, we have x to the 3rd raised to the 2nd. That's like saying we have 2x to the 3rd. Power being raised to a power, you multiply the exponents. And that ends up being x to the 6th. Switching, well, I shouldn't say switching gears yet, maybe in the last one. In this case, these brackets, all these brackets mean, ladies and gentlemen, are parentheses. Usually when there's a set of parentheses, instead of making a double set of parentheses, I shouldn't say usually, but sometimes they put brackets. In this case, what this means is we have -2 raised to the 3rd and then raised to the 4th. This is a power raised to another power. So treat it just the same as we did up here. -2 multiply your exponents, 3 times 4. And we'd get -2 to the 3 times 4, which is 12. Now the last one deals with that last property. No, I'm sorry, it doesn't deal with that last property yet. It makes me want to think of dealing with the last property. But since this is subtraction, not multiplication, be careful. We can't just say a to the 3rd and 2 to the 3rd. That's not what this means. We have a power right here, a to the 2nd being raised to the 3rd, and then raising it to another power, to the 2nd power. Leave your a minus 2, and then just multiply 3 times 2. If you do that, we get the quantity 8 minus 2 raised to the 6th. That's your answer. Don't try to take it any further, because this does not mean a to the 6th minus 2 to the 6th. This means you have 6 a minus 2's. Okay? So again, whatever your base is, if it's being raised to a power and then to another power, you multiply the exponents.